In this video, we're going to talk about finding the rate of growth or decay from an exponential function. So just as a reminder, y equals a times b to the power x is your exponential function. The a value, or the number in front of the base, is always the initial value. That's the starting amount. Then b is the base, and the base represents either growth, if the base is bigger than 1, or it represents decay if the base is between 0 and 1. Now, another way we can think of the base is as a percentage either above or below 100%. So, just as an example of finding the growth rate and thinking about that as a percentage, if we have y equals 2 times 1.05 to the power x, then 2 is our initial value, and 1.05 is the base. So that base is going to tell us whether this is a growth or decay function, and since this is greater than 1, it's a growth function. Now, if you were asked what is the rate of growth, then we would need to think of this base as a percentage above or below 100%. So we're going to take the base and multiply it times 100. So we're going to take 1.05 and multiply it times 100 to get our percentage, which is the base. So 1.05 times 100 is 105%. Now we're going to ask ourselves, how much higher than 100% is that? So if we're thinking about 100% being like the initial amount, then we are at 105%, which is 5% more than that. So we would look at 105%, and essentially we're subtracting the starting amount, which would be 100%. So that leaves us with a 5% growth rate. Okay, now let's look at one when you have decay. If we have y equals 3 times 0.37 to the power x, 3 is the initial value, so that's the starting amount. And b, the base, for this example, is 0.37. So we want to know how much lower than 100% is this. Since this is less than 1, we know that it's decay. So we're going to take our base and multiply it times 100. So that's 0.37 times 100, which is 37%. So that 37%, how much lower than 100% is that? That's how we find the decay rate. So we're going to take 100% and subtract 37, and that's going to give us our decay rate. So as a summary, to find the growth or decay rate, essentially all you're doing is finding out how much higher than 100% or how much lower than 100% is that base number. Now let's look at some more examples. In number 1, we have an exponential function. We want to identify the base, the initial value, whether it's growth or decay, and then find the rate. So basically everything that we just did. So the initial value is a, so just as a reminder, if you have y equals a times b to the power x, a is the initial value, b is the base. So here our initial value is 2. The base is 1.19. Now, since that base is greater than 1, that is going to represent growth. Now we want to know what is the rate of growth. So what is that percentage of growth? So we have to think about 1.19 as a percentage. So we're going to do that times 100, and that gives us 119%. So how much higher than 100% is that? Well, essentially we're just doing 119% and taking away the original 100 from it, and we get 19% as the growth rate. Okay, let's look at number 2. Here we have an initial value of 4. The base is 0.89 or 0.89. Now, since this is less than 1, that represents decay. Now, how would we find the rate of growth or decay? Well, we're going to think of the base as a percentage, so we're going to do 0.89 times 100, and that gives us 89%. So 89% is less than 100%, but how much less? That's what tells us the rate. So we're going to do 100% minus 89%, and that gives us 11% of decay. In number 3, this one looks a little bit different because you don't see the initial value written out, but we can do that so that it looks like y equals a times b to the x. So we have y equals, but we see that the number with the exponent, that's our base, and since there's nothing in front of it in parentheses, we can put a 1 there. Okay, so now it's easier to see that the initial value is 1, the base is 2, and since our base is greater than 1, that's going to represent growth. Now to find the growth rate, we're going to have to do that same process that we did before. So if we had 2 and we want to write that as a percentage, that's not 2%. We're still going to have to do 2 times 100 to get our percentage. So that's actually 200%. And then to find how much greater than 100% is that, we're going to say if we have 200%, we want to find out how much larger that is than 100. So we're going to do 200 minus 100, and that gives us a 100% growth rate. All right, number 4. Again, we do not have the initial value written in front of the base, so it's understood to be 1. Okay, so our initial value is 1. The base is 0.73, and 0.73 is between 0 and 1, so that is decay. Now we want to find what is the rate of decay. So we're going to take our base, 0.73, and turn that into a percentage. So we're doing times 100, and that gives us 73%. Now how much less than 100% is that? So we're going to do 100% minus 73% to find our decay rate. So that would leave us with 27% as our decay rate. In number 5, here we do see the initial value is 0.2. Now remember, the initial value is not what tells you growth or decay. Our base, which is 3, is what tells us growth or decay. So since 3 is larger than 1, this represents growth. And we want to find what is the growth rate. So again, 3, that's our base, but that does not represent 3%. We have to change it to a percent. So we're going to take our base, 3, and multiply it by 100 to get our percentage, which would be 300%. Now we have to say how much greater than 100 is that. So we would say 300 minus 100 and get a growth rate of 200%. That means that this function is increasing by 200%. In number 3, we have an initial value of 3, and the base is 1.12. So now 1.12 is greater than 1, so this represents growth. And we want to know what is the growth rate. So we're going to take 1.12, our base, times 100, and that gives us 112%. So now how much greater than 100% is that? So 112 minus 100 is a growth rate of 12%. Okay, number 7. Our base, now notice this function, this equation is written a little bit differently. This dot in the middle still represents multiplication. So if you need to rewrite it with the parentheses, that's perfectly fine. That doesn't change anything about this function. So our initial value is still 2.3. The base is still 1.009. And since 1.009 is still a little bit greater than 1, that is still growth. Okay, now pay close attention to this one because the decimals in this one are a little bit different than any that we've done so far. So we're still going to take our base and multiply it by 100. Now this time we're going to get 100.9%. Okay, so 100.9% is still a little bit greater than 100%. So we can still find our growth rate by doing 100.9% minus 100%. And 100.9 minus 100 just leaves us with 0.9%. And that is our growth rate. So this one was a little different because it has a percentage that is a decimal, but that is okay. That happens sometimes. Means it's not growing, it's not quite growing by 1 whole percent. Okay, number 8. We have 0.91 to the power x. So once again, we do not have the initial value written, but it is understood to be 1. So this is the same as y equals 1 times 0.91 to the power x. So our initial value is 1. The base is 0.91. And since 0.91 is between 0 and 1, that represents decay. Now we can still find how much less than 100% is this base. So we are going to take 0.91, our base, and multiply it by 100 to turn it into a percentage. So that means 91% is our base. So that means that this function is less than 100%, so it's decaying, but by how much? So we want to know 100% minus 91% is our decay rate. So that would leave us with a 9% decay rate. Okay, number 9. Again, we have this function. It's written with the multiplication dot in the middle, so if you want to write the parentheses around the base, that's fine. Okay, our initial value is 0.33 or 0.33. Our base is 1.003. So this is going to be kind of similar to number 7. Okay, so 1.003 is still larger than 1, so it's still growth. Even though it's not much larger than 1, it is still growing. And to find how much it's growing by as a percentage, we're still going to use that same process. Take our base, 1.003, times 100 to turn that base into a percent. So that would be 100.3%. Then we are going to find how much larger than 100% is that. So 100.3% minus 100% leaves us with 0.3% growth rate. So it's not growing by a whole percent, but it is still growing by 0.3%. And finally, number 10. This one is pretty straightforward. Our initial value is 3. The base is 0.74. And 0.74 is less than 1, so that represents decay. Now to find how much it's decaying by as a percentage, we are going to turn 74 into a percent. So 0.74 times 100, and that gives us 74%. So now how much less than 100% is that? So we're going to take 100% and subtract the 74% to see how much that is decaying by. So 100 minus 74 is 26. So that's a 26% decay rate.